Yeah, Abhinav. Now I
Am
can
I
hear
audible
you.
to you? Good morning, sir.
Yeah, yeah. Good morning. Good morning.
Actually, my mic was giving me some problem.
Okay.
I
Now
just
I can
changed it.
hear you. Yeah.
Okay, okay, fine. So you are asking what are the concept we have learned. So
No,
starting,
no, no. No, I
okay.
am not asking. What concepts are the concepts okay? Is it understandable or have you faced any difficulty in week
Yes, sir. Yes, sir. The
in
level
the
of difficulty is as slowly starts increasing, and
Hmm.
yes, there are some questions. In fact, after learning those concepts, also the questions are not solvable, and
Okay.
we would
Can
like to
you be
request you
more
that some.
specific? Specific like which week?
I have started making the list of all those. I'm summarizing all the weeks. I'll
Hmm.
be putting up those questions in the coming this session. You have started new thing called TA session with TA.
Yeah, yeah, yeah.
Yesterday there was one, but I don't know. I tried all my best to join it, but I could not able to join it. Nobody
Hmm.
approved. You know my request.
Okay.
So I don't know whether it happened or not. Also.
Okay. Okay, so you are just going through your summary, and once you
Yes,
are
sir. Yes,
done,
sir.
you will come back to us.
Sure, sir.
That is what you. Okay.
Yes.
Okay. Huh. Harsh, Harsh Kumar, Pooja, Sarvani.
Yes, sir.
Yeah, Harsh Kumar. So, how was till week six? How was your experience till week six?
Sir, it was good, but actually in questions like what problem we face difficulty.
Mm-hmm. Okay. Once it is explained, then it is easy. Is it?
Yes, sir.
Are you unable to understand it or any other problem?
Sir, I have understood all the concept, but in the questions of what problem to apply
Hmm.
it, I find difficulty.
Okay. So the application part. Hmm? Okay.
Yes, sir.
Okay. But the concepts are okay, right? Like whatever we learn, like logarithms or
Yes, sir.
exponentials or
Concepts
inverse
and their
functions.
properties are understood.
Oh, okay. Okay, fine. So good. Are there anyone who didn't understand concepts also? Like what is this inverse function? What is this composite function? If you are silent, I will take it as no.
So like the concepts are clear for me, but simplification is a bit hard for me. I'm not
Hmm.
able to do it. I'm practicing it for last 3 4 days, but still I can't.
Okay. Simply, what is simpli? What do you mean by simplification?
If a given expression, like we have to simplify the expression or find the value of.
Oh, simplification or okay, you are talking about exponentials or logarithms, I hope.
Logarithms.
Hmm.
Exponential are fine.
So, hmm. See, just like just like exponentials, logarithms do have properties in it, right? Can you tell me one or two of it?
Like log of kind of that a and plus b that will be multiplied,
Log a b it will be log a plus log b.
and log a of a is 1. Yes.
Log a to the base a is 1, and log a by b is log a minus log b.
Yeah,
Correct.
that's it. Yes,
So,
sir.
in these simplifications, you more or less use these kind of things. And one important property is a to the power log x to the base a will be x. Okay, a to the power log x to the base a
Yes, sir.
will be x. So there are few properties. Just go through them. Okay, just a second.
Oh, yes.
Yeah, sorry for that. Yeah, Pooja, continue. Please continue.
Yes, sir.
Hmm.
No, just I'm difficult in
So,
these steps.
so these simplification things, we will use these properties and we will simplify the terms.
Yes, sir. I
Okay.
have gone through the properties, but where to apply that particular thing, that's kind of, it takes
Acha.
time for me.
Will take. So practice more problems. That is what we suggest. Okay.
So,
More and more
yes.
problems. Okay. Okay. Fine. Fine then. So in this today's session, we will start with week. So we have just completed our set theory and basic functions and their properties. Now we will look into, I don't say difficult concept, it's rather minute concept. So we will look into small details like dx. So wherever dx comes into the picture, that will fall under calculus. So we will see functions and their behavior within a small interval. And yeah, let me share my screen before that. Is my screen visible?
Yes, sir.
Yes, sir.
Yes. So week 7 will start from again revising week 1 to 6, because this week 7, 8, 9 initially it was in max 2, but later we thought this also should be taught in max 1. So that is why we have pushed it into max 1. One or two lectures in this week 7 will consist of revision of week 1 to 6, and then we will study functions of one variable and how are these graphs and what is the tangent to a graph. Then comes the new topic, limits for a sequence we are going to see, and limits for functions of one variable. So these are the concepts that are in week 7. Then from week 8 we will look at continuity, differentiability and everything. So just give me one more minute. My pen is missing. Just give me one more minute. Yeah, am I audible?
Yes, sir.
Hello?
Yes,
Yeah.
sir. Yes, sir. Yeah.
Okay. Okay, let us start by one. So why I'm taking this session is because I hope no one has gone through the week 7 lectures yet, because yesterday itself week 6 deadline has passed, right? So let us recall or let us revise what all the concepts are there in week 7 today, and in the next session we can discuss the doubts.
Okay, sir.
Okay, is that okay?
Yes, sir.
Yeah.
Yes, sir.
Okay, then let us see. So these are the things we require for week 7 at least. So these are the things that are compulsory required from week 1 to 6 in order to understand week 7, 8, 9 clearly. So what is a domain? What is a range? So what is a domain? If I have any function, a function defined from R to R. So what does this R mean? So while we write this f R to R, what does this mean basically?
Real to real.
Okay, real to real. What is that real to real means?
So if we input any real value, we are gonna get real output for that function. Real value. I mean, value on the real line.
So this means, so this particular thing means a function defined from set R. So this is set. This set R. So this is 2, another set R. Okay, let me say to some C. So set C. Okay. So this particular denotion, what we are denoting every time, F semicolon R right arrow to C, means this is a function defined from. So these are two sets. R and C are two sets, and from one set to other set we are mapping. So function is a mapping. So this left side set, or from where you are mapping, that particular set is called domain set, and from that domain set we are going to take our inputs. So in this domain set, the set of all inputs, the set from which the function takes its inputs, or the set of all inputs that can be put in the function. So this is called domain set. Simply we will call it as domain. But domain is a set. You have to remember that. It is a set of all the inputs that a function takes. Okay. And there is codomain. So what? So as this is domain, the other set is called codomain. And this codomain is where the set where we expect our output. So it's not the set of all outputs, it's the set in which we expect our outputs. So that is our expectation. So you can keep R itself. So my C can be R, set of all reals. Output. So in this particular set of all reals is my expected output. So codomain means the set in which I expect my output, and range is subset of this codomain, which is the set of all outputs. So when I input some value into my function, I will get some output. Likewise, if I input all the inputs into my function, whatever the outputs I get, I will keep it as a set and I will call that set as a range. So that is range. So these are important things. You have to be very clear about these things. What is domain, range, what is codomain, and then it comes the definition of the function. So this is the function definition. So for a function, a single point in the domain or a single value in the domain cannot give two different outputs. That means, so if I input one value into my function, if I input some point into my function, it will only give a single output, not different outputs, or not more than one output. Okay, so it has to give only one output. For an input, I have to get only one output. So that is the definition of a function. And you can see every machine or every machine or computer or whatever, phone. So if I input, if I wanted to open WhatsApp, if I click on WhatsApp icon, it will open me WhatsApp only. It will not open multiple applications at the same time. So I am giving an input to my function, input to my machine, and that machine works according to my input. So if I ask him to do, if I ask my laptop to share my screen, it will only share the screen which I am sharing. It will not do something else at the same time. So for every input, there will be only one output, that is called function. And every machine is a function. I hope it is clear now.
Yes, sir.
Now,
Yes, sir.
Yes, sir.
so once we understand function, then we have seen different types of functions. So in week 2, we have seen straight lines. Straight lines are nothing but linear functions. So you might have seen of this form, fx is equals to ax plus b, and the graph of this will be like this or like this. So this will have slope positive, this will have slope negative.
Negative.
So these are two kinds of straight lines you might have seen. So okay, here the slope is a. Let me denote it as a only. A greater than 0, a less than 0. And there are two other types, which is horizontal and another thing is vertical. So we are not bothered about these two lines in our week 2 also. So we have focused more on these lines. So where slope is positive and where slope is negative. So how are their behaviors? And we have seen lots of application problems on these straight lines also. So once after you learn straight line is of linear function. So it has linear term ax and a constant term b. And then in week 3, we have seen what is a quadratic function is. Quadratic function is also a different type of function where my leading degree is 2. So you can see this is quadratic term. So once if I have quadratic term in my function, then those functions are called quadratic functions. And here also there are two types of graphs you have seen. If I have to draw a graph, so one is upward parabola
And downward
and the
parabola.
other one is downward parabola. So even these two can also be found by seeing the function. When a is greater than 0, it will be upward parabola. A is the leading coefficient. So you see, leading coefficient plays an important role. Even in linear functions also, even in quadratic functions also, the leading coefficient defines the graph. So when a is greater than 0, it is open upward. When a is less than 0, it is open downward. So these are the two types of parabolas we have seen in week 3. And these are the possible graphs for quadratic function. So it will not take any other type. Hmm. Any doubt?
No, sir.
Okay. Okay. So even in week 3 also we have seen many application problems where we use quadratic functions. And then in week 4 we started looking at functions or the polynomials. Polynomials means which have degree more than or equal to 2. So even quadratic function is a polynomial, even linear function is also a polynomial, but in most of the books we don't see linear functions into the polynomials. They will be dealt separately. Even linear functions are also polynomials. So okay, even here here also you can see polynomial function means even it also takes this form like an. So there will be some coefficient attached to each of the terms. This is nth term, n minus 1. So x to the power n plus an minus 1, x to the power n minus 1 plus, and so on, a1x plus a naught. So this is the form of a polynomial function where n generally n should be greater than or equals to 1. But in our course we will deal n greater than or equals to 2. So n should always be greater than or equals to 2. Okay, as I takes 0. Okay, let us deal whatever mathematics is. N greater than or equals to 1. So that means even linear function, quadratic functions, cubic functions. Cubic functions means like this: x cube plus x square minus x plus 1. So the leading power is 3 will be called as cubic functions like this. So these are called the polynomials. So where it has real coefficients. So see, ai should be real coefficient attached to the powers x to the power n. N is an integer. Okay, so here it is not given. So n is basically a natural number greater than. So n takes values 1, 2, 3 and so on. So only natural numbers, not the rational numbers or something else. So like this, x to the power 3 by 2 is not a polynomial function. X to the power 1 by 5 is not a polynomial function. So whatever the power x to the power something, that something should be a natural number. Then only it can be called as polynomial functions. Okay, this form, in this form. And even here also we have seen 4 types of polynomial functions. So can you tell me what are those 4 graphs? 4 kinds of graphs we have seen. Okay, basically 4 kinds, I mean the end
Upward,
behaviors.
downward.
Yeah. So both the end behaviors are upward, both the end behaviors are downward. And one left side is up and right side is down. And right side is down and left side is up. Sorry, left side is down and right side is up. So this is a case where my leading coefficient is greater than 0 and it is an even degree polynomial. So even degree, when I mean n is even. So when this particular n is even, that means n takes values 2, 4, 6, 8 and so on. When n is even and your leading coefficient an, if your leading coefficient an is greater than 0, then this kind of behavior you can see. Both the end behaviors will be in the plus infinity side. Similarly, when an is less than 0 and n is even. So your leading coefficient is less than 0, but the degree is even. Then you can see both the end behaviors will go to minus infinity. And this graph is an greater than 0 when n is odd, and this is an less than 0 when n is even. Okay, so the graphs of polynomial functions will be depend on the leading coefficient and the degree of the polynomial.
Sir, I have a confusion, sir.
Hmm.
In n an is less than 0,
First,
then n is
first,
even. How, sir?
not
This
even.
third
This
one.
is odd.
Okay, yes, sir.
Yeah. Or
I have a doubt in this type of question, like like polynomial function of degree n. So in the examination, there was like a highest degree of x was 10. Then in answer sheet we get the answer that the degree of the polynomial is 5. Then how it was?
no, I missed something in between. Maybe I lost connection. Can you repeat?
Sir, in a qualifier exam,
Hmm.
the same polynomial functions are given where the x degree was highest 10. Then in answer sheet we get to know the answer is 5.
Hmm.
So,
Okay.
can you please
Sir,
explain
there
this?
the coefficient of a
Yeah,
equals to
coefficient.
0, so
Yeah,
that
it was 0 into x to the power 10, I guess.
Acha.
Yeah,
I have to open
yes,
the question then.
yes, sir.
Yes, so the coefficient was like 0, so we have to take the next one.
Let me just open. In the quiz, is it? Qualifier.
Yes, sir. Qualifier.
Okay.
If those
So P
question.
of x is given to be something like a times x to the power 10. For you, it is 10, is it? So it was given in one of the MSQ questions, right?
Yes, yes, sir.
One of the option in MSQ. So there you can see the leading coefficients. Leading coefficient is B, not A. A is given to be 0. So here itself you see. So here you see when this
So can you
AN.
share the question, sir?
Hmm?
Can
The
you share
question.
the question? Yes.
Just a second. So this was the question, right?
No, not this one, sir. Not this question.
See, maybe power might change, but this
No,
is
no, no, not this question. Yeah, okay. It's for yeah. It again one question was there similar type. Y-
the only question we have. Maybe the set might change. So in your set, the power might be different.
Yes, I think so. Yeah.
So you might have got something
Yes.
like a times x to the power 10 plus b
10.
times
Yes.
x to the
Yes. Yes.
power 5 something, right?
Yes.
But it is here you see we have given a is equal to 0 and b not equal to 0.
Oh,
Okay. So when a is 0, if I substitute 0 times, you can see the solution. This solution will be uploaded soon. So 0 times x power 5, this will not be a term at all. This will vanish off. And the remaining polynomial will be some b x to the power 4 plus 2x plus 8, where b is not equals to 0. So therefore, degree of this p of x will be 4, not 5. Okay.
okay, sir. Got it.
So the highest power will be the degree, right?
Highest power will be the degree when the coefficient of that highest power is not equal to 0.
Yes, yes, right, sir. Right.
So your an should not be equal to 0. Okay, then only I will call this polynomial function of degree n. If an is 0, then the polynomial degree might be maybe n minus 1. It will not be n. Okay, so this is also an important thing. Our an, which is the leading coefficient, should not be 0. Then only it is called polynomial of degree n. Okay, and these are the 4 kinds of polynomials possible, and we have seen problems on this also in week 4. Then in week 5 we have seen exponential functions. So exponential functions will be of the form f of x is equals to a to the power x, where a is real. And also there are many conditions, a not equal to 1. Sorry, a should be greater than 0. Right? A should not be real. So whatever we studied is a greater than 0 and a not equals to 1. Is that correct? So what is the domain of an exponential function?
Real numbers.
They're all real numbers.
What is the range?
0 to infinity.
To infinity, excluding the 0.
Correct. So for that, we have some restrictions on a also. So a should be greater than 0 and a should not be equal to 1. So when a is equals to 1, it's a constant function. So 1 to the power anything will be 1. So it will be a constant function. So that is why we ignore 1. And why shouldn't a be less than or equals to 0?
Because the codomain is a complex number then.
Yes. So codomain, we expect our outputs to be in the set of reals. So an exponential function is defined like this: f from r to r. So we wanted to expect our output should be reals. If I take negative value for a, sometimes my output will go okay, complex or not real values. I will get outputs as not real value. So in order to exclude that, we take a to be positive. A should be greater than 0 is an important condition in this particular course. I don't say we should always take a greater than 0 for exponential functions. So in this course, we are not dealing with complex numbers. So we want our outputs to be expected in the set of reals. So my codomain is set of reals. So for that to be true, my a should be greater than 0. So that is why we have took a greater than 0 is also a condition. And domain of exponential function is r, and range of exponential function is 0 to infinite excluding the endpoint. And similarly, not similarly, the inverse function of exponential function is logarithmic function, which will be of the form f of x is equals to log x to the base a. That is how we read log x to the base a. And here also, see, as I said, it is an inverse function. Whatever the range of exponential function is, that will be the domain of this logarithmic function. So domain will be 0 to infinite, and whatever the domain for exponential function, that will be the range of the logarithmic function. So the range will be minus infinite to plus infinite, which is set of reals. Okay, here also the same conditions hold. A should be greater than 0 and a not equals to 1. So these are about functions, and then few concepts also we require in order to understand week 7 properly. So first thing is, what is an increasing function and what is a decreasing function? So a function f is increasing if I take 2 points, 2 inputs, basically x1 and x2 are inputs. If I take 2 inputs, one is less than the other, like if x1 is less than or equal to x2, that should imply me my outputs will also follow the same sign. So if I take 2 inputs x1 and x2, my outputs are f of x1 and f of x2. If x1 is less than or equals to x2, that should imply me f of x1 is less than or equals to f of x2 for any. So x1 and x2 belongs to the domain. So for any two, okay, for all, it should satisfy for all x1 x2. So whatever x1 x2 I take, if x1 is less than or equals to x2, then I should get f of x1 is less than or equals to f of x2. Then I conclude f is an increasing function. So you can see in this figure A, this graph. So I take 2 inputs, 2 and 3. So 2 and 3 are my inputs. Now x1 is 2, x2 is 3. Now if you observe closely, if I talk about f of x1, so f of x1 is something this, maybe 0.5. F of x3 is 1. So f of x1 is 0.5 and f of x2 is 1. So you see 2 is less than 3, which is implying me 0.5 is less than 1. So the same sign is being followed not only for 2, 3, whatever x1, x2 I take. So you take 3 and 4 also. 3, 4. So f of 3 is less than f of 4. 3 is less than 4. F of 3 is also less than f of 4. Like this. So any 2 points, this will always satisfy this condition for this graph. This graph. So I conclude this particular function f is increasing. Okay. From the graph also you can see you are drawing from bottom to top. So the graph will also go from bottom to top. If I start from left side and if I wanted to draw the graph, so I have to go to top. So my function value should increase as I go along positive side of x. So like this. So this, all these things, these all are increasing function. So you can see it is going from bottom to top. From the graph perspective, you can guess whether it is increasing, or you can conclude whether it is increasing or decreasing by looking at the graph also. So if it is going from bottom to top, from left to right, it is an increasing function. So possible increasing function graphs are like this. So it may be like this or it may be like this. But in the both cases, the left side value will be lesser than the right side value. So that is increasing. For decreasing, it's just a sign change. So when x1 is less than or equals to x2, my f of x1 will be greater than or equals to f of x2. Okay. So the same thing, this graph now. You see this graph. This downward going graph. From top to bottom it will go. And here you can see f of 2 and f of 3. F of 2 value is greater than f of 3. So 2 is less than 3, but f of 2 is greater than f of 3. So there is a sign change. Okay. So if I have function with me, this is how I have to check. If I have graph with me, you can directly see where if it is going from top to bottom. So from top to bottom, that is a decreasing function. That is how you can see from the graph. And if you don't know the graph, if a function is given to you, function is given to you like this. So tell me, is this an increasing or decreasing function?
Increasing function.
Increasing function, sir.
Increasing function. So you can see, if I take x1 less than x2, I look at f of x1. What is f of x1? So 2x1 plus 3. And what is f of x2? 2x2 plus 3. So by taking this, if I can prove this, then I am done. So can we do? Can you come from here to here?
Yes, sir.
Yes, sir.
X1 is less than or equals to x2. So I just multiply 2 on both sides.
And then add 3 on both sides.
And then add 3 on both sides, you will get 2. So multiply 2, and then add 3. You are going to get this. Then this implies f of x1 is less than f of x2 for all x1, x2 in the domain. So I didn't take the values here. I just took x1, x2 as variables only. Then also I got this condition. So I can say this is an increasing function. So this is increasing function. Okay. Like this you have to prove. If a function is given to you, you can prove it like this. If you know the graph of the function, it is very easy. So just look at the graph. If it is going from bottom to top, it is increasing. If it is coming from top to bottom, it is decreasing. Okay. And yeah, this also, you see, this is an x square, somewhat x square kind of graph. Okay. So this graph is a decreasing function till 0.
And 0 to infinity, it's increasing.
It's increasing. So this portion is decreasing, and in this portion it is increasing. So you can take two values and check also. This condition will be satisfied in this region, and this condition will be satisfied in this region. So on and whole, if I look at on and whole throughout R, this function is neither increasing nor decreasing. So we cannot say throughout the domain it is decreasing or throughout the domain it is increasing. Okay. At few, in some interval it is decreasing and in some interval it is increasing. That is what I can say. But on and whole, it is neither increasing nor decreasing. Okay.
Okay, sir.
Yeah. So let's move a little forward. So you can see this also. Both the functions are increasing. And you can see the domain and range also. What will be the domain and range? So this is just a straight line. So domain and range both will be set of reals. Even here also it is somewhat x cube graph.
It
So
would be the
domain
same,
is
right?
R, range is also R. But here you see this is an x square graph. So the domain will be set of reals, but the range will be different. Range will be from 0 close to infinite. So the set of all possible outputs.
So it's a positive real line, sir. I mean, the
Yeah,
range.
positive.
Okay.
Range is positive. Positive real. Okay. So these are the things. And presents a function. There are few questions, I guess. Okay. So you just do this thing then. Just now we discussed what is increasing, decreasing. How should we check whether it is increasing or decreasing? So observe this figure. Okay. So observe this figure and let me give you options. So minus infinity to minus 2, it is increasing. Option B is minus infinity to minus 2, it is decreasing. Option C is minus 2 to 2, it is increasing, and option D is 0 to 2, it is decreasing. Okay, so this is
Should I say it right now?
B and D.
B and D, sir.
B and
Option B and D.
option
B is
B
right,
and D.
B and D.
and D is right.
Correct. So
Yes.
B and D is correct. By looking at the graph, it is very easy. So it is coming from top to bottom in the interval minus infinity to minus 2. So from top to bottom means it is decreasing. So this is correct. So this is decreasing. And from minus 2 to 0, you see it is going from bottom to top, it will be increasing.
Increasing.
And from 0 to 2, it is
It will be
coming from
decreasing.
top to bottom, it is decreasing. And from 2 to infinite, it will be increasing. So you can check. So minus 2 to 2, it is given that minus 2 to 2, it is increasing. But it is increasing till 0 only, then onwards it is decreasing. So this option is incorrect. So even this is also incorrect because minus 2 to minus 2, minus infinity to minus 2 is decreasing. It will not be increasing. And the final one is 0 to 2, it is decreasing. So just check 0 to 2, it is decreasing. Correct. So like this, there are other 4 options also. See, you see here. In the interval minus infinity to minus 2, the function is increasing. So it is false. And in the interval minus 2 to 2, it is decreasing. It is also false. It is neither decreasing or neither nor increasing. So I just said right. So on and whole in this interval, if it is some region it is increasing and some region it is decreasing. If I look at on and whole, it will be neither increasing nor decreasing. So this is also incorrect. And in the interval minus 2 to 0, the function is increasing. Minus 2 to 0, the
This is
function
true,
is
sir.
increasing. Correct. And in the interval 0 to 2, the function is decreasing.
This is also true, sir.
This is also true. And in the interval 0 to infinite, the function is increasing. Again there is, you see, so 0 to infinite. So 0 to 2, it is decreasing, and 2 to infinite, it is increasing. So decreasing and increasing in the same interval. So therefore, it will be neither increasing nor decreasing. Okay, this is also false. And in the interval 2 to 3, the function is increasing. This is correct. Okay. Now it is clear how to check increasing, decreasing, if a function is given or if a graph is given. Okay.
Yes, sir.
Okay. And let us look at some properties of functions. So if I have two functions, what is sum of two functions, difference of two functions, product of two functions, and division of two functions. So f plus g is a new function now. So this is called sum function. So f plus g of x, you can write it as f of x plus g of x. So that is the property of the functions. So you can split the functions and separately compute the value. Similarly, for minus difference also, f minus g of x, if I wanted to compute, I can compute f of x and I can compute g of x, and I can just see the difference f of x minus g of x. And product is also same thing. Fg is a product function. It's a new function. Fg of x can be written as f of x into g of x. So if I just take an example, f of x, let's say it is 2x, and g of x is, let's say, x square. Now if I wanted to compute f plus g of x, so f plus g is the sum function. So f plus g of x is basically 2x plus x square. Okay. So this is 2x is f of x and gx is x square. So f plus g of x, you can write it as f of x plus g of x. Okay. And this is a sum function. So this is a new function. You can h of x, you can treat it as 2x plus x square. Just the sum of two functions. Okay. and the difference is also easily seen. F minus g of x. So f minus g of x is basically 2x minus x square. So f of x minus g of x. Like product fg. Now fg of x is just the product of these two functions. It will be 2x cube. So 2x cube, I can write it as 2x into x square, and it will be f of x into g of x. So the product function is 2x cube, 2x minus x square. So you can see, right, these are all new functions. This is neither f of x, neither g of x. So this 2x plus x square is some other new function. 2x minus x square is also a new function. 2x cube is also a new function. These functions are just the sum function of f of x and g of x. This is the difference function, or there is no such kind of thing. It's just the difference of these two functions. And this is product function, product of f of x and g of x, 2x cube. Okay, so and finally the division of two functions. So f of x by g of x. So f by g is the division function. F by g of x, you can write it as f of x divided by g of x, given that g of x is not equal to 0. So this should hold. My g of x should not be equal to 0. Okay, because it is in the denominator. If it is 0, it is undefined. So 1 by 0 is undefined. Okay, so here only you take. So g of x is x square, and also I know that let's take x is g of x is not equal to 0. Therefore g of x will not be equal to 0. Then I can compute f by g, which is 2x by x square, which is 2 by x. Now this 2 by x is the division function, division of these two functions, f of x and g of x. This is a new function now. 2 by x is different function from 2x and x square. So this is a division function, and this will be 2 by x only if x is not equal to 0. X should not be equal to 0. If x is equal to 0, that is not true. Okay. They have given example also. Just try to do this. Answers are anyway given. F of x is this, g of x is this. Now compute f by g of 2. Just check f by g of 2 is 11 by 3 or not.
It is, sir.
It is, right?
Yeah.
It will be. So f of 2 will be, this is simply f of 2 divided by g of 2.
Yeah.
F of 2 will be 4 plus
4
4
plus 2
plus
plus
3.
4 plus 4 plus 3. Yeah.
Yeah, it will be 11, and it is
2
g of
plus
2
1
is
3.
basically 2 plus 1 3. So 11 by 3. This is okay. But if you see this f plus g of 1, so just substitute 1. F of 1 will be 6, and g of 1 will be 2. 6 plus 2 will be 8. It will not be 7. So this is false. Similarly, you can see here 2 times f. So hint is given to us. So any constant is multiplied to the function. Just remove the constant out. Bring the constant out. So 2f of 3. This is basically 2 times f of 3. So f of 3 is 9 plus 6 plus 3. 15, 18. So 2 times 18 will be 36. So it will not be 18. So like this you have to check. Okay.
Yes, sir.
Now let us see composition of two functions. So if I have two functions with me, where f is from the domain set is D1 to set of reals, and g is from D2 to set of reals, be two functions, and this is important, range of f is subset of domain of G. Okay, so why is it important? You will get to know now. So if this condition is, if this is true, if my range of F is subset of D2, then the composition can be found directly. So the composition of two functions can be defined like this. So G circle F, now this is a composite function. This is also a new function now. So look it as a function only. So G circle F is also a function which is composition of two functions. So what it is, G circle F of X can be written as G of F of X. Okay. So this X will go into this function F, and this F of X will go into function G. So like this, there are two machines, F and G. So my X will go into this machine and it will come out as F of X. And why this is important is because whatever F of X comes, that will be the inside the range. Correct? If this particular range itself is in the domain of D2, then whatever F of X comes, that can go into function G. Because my range of F is subset of D2. So all the elements will go into this function G, which are in D2. And the range of F is also a subset. So all the elements which are range of F, all the elements present in the range of F will go into the function G. So this will be, so if I input X, it will go into this machine F and it will come out as F of X. And this F of X will go into this machine G now, and it will come output as G of F of X. So you see, if you input, now input becomes F of X now. Input for G becomes F of X. So whatever input F of X goes, my output will be G of F of X. So on and whole, if I look at combining these two machines, outside view, if I input X, my output will be G of F of X. Okay. So this is inside. You don't know what is happening inside a machine. So you just see, let's take an example. How many of you know this chili, how this chili powder is made from red chilies?
They have
Chili powder,
By drying them first
drying them, and you
and grind.
just you grind it,
Yes, sir.
but this grinding will be done in two stages. So you grind once, and whatever the grinded item is there, it will not be refined.
Yeah, like
Again,
fine,
you
Yes,
will,
sir.
fine
Yes, sir. Yes,
powder.
sir.
Yeah.
for fineness, you will again
Again
throw it
grind
into
it.
the, again grind it. Correct?
Yes, yes, sir. Yes, sir.
So let's assume you don't know what is happening inside a machine. So this is the outside machine. You just put chilies, red chilies, inside that machine. It will give you two stages of processing, and it will give you the fined powder, chili powder. Okay, that is what you can see. So first of all, that chili goes into one machine and it will get refined. Half it will refine. That will come as an output, and that will go into the other machine for fineness. And finally, you will see this output. So the fined chili powder will come out. Okay, so that is what.
Yes, sir. Yes.
So the composition of two functions. So it's two machines working, but you don't know what will happen inside. But you know the input you can see and the output you can see. So the input is X and the output is G of F of X. So this is the composition of two functions. Are there any examples given? Yeah. So try this now. Let F of X is given to be X by X plus A, where X is greater than 0. See, these conditions are very, very important. So sometimes it may help you, if it is an MSQ or MCQ, it may help you to exclude options. So you can exclude few options and you can guess the answer also. So the conditions are very, very important. So it is given that x is greater than 0 and a is greater than 0. And also it is given that f of x is equals to x by 3x plus 4. Now find the value of a.
Sir, the hint is here given, but last night when I was doing, that was my same approach actually, as the hint.
Okay. So you got the answer or no?
Yeah, yes, sir, yes, sir.
Okay.
Yeah, that-
So hint is given here, you can check. Just substitute in place of f of x, just substitute x by x plus a. So you will get the answer. Okay, just try. You will get 2. That is about the composition of two functions and about properties of functions also. How to add two functions, how to subtract two functions, how
Sir,
can we product two functions.
sir, I just have a question. I mean,
Hmm.
about any kind of equation. If we find it identical on the both sides, can we just say the value is like this? For example, let's say we have 2x plus 2 square or 4, and on the other side we have a square plus 2x, like we used to do in school, like identical. So we just form the
Acha.
both sides in the same, and then we just assume that the unknown quantity is something on the other side, like that. Can we say that same?
See, that is one possible value.
Yeah. I mean, is that like
It is okay, but it is one possible case. See, this is a quadratic function now, quadratic
yeah.
equation now. Okay,
Yeah.
it will have two roots
Two roots, yeah.
basically. Yeah, so one root is a, definitely for sure.
Hmm.
Okay,
Okay,
so if you
okay.
substitute a, you will get the both left hand side and the right hand side will be equal. So
Mhm.
x is equals to a is a possible value.
Alright,
But there will be another root also, another possible value also. Once you solve this quadratic equation, you will get that value also.
alright, alright.
Okay, so,
Got it.
so equating it will give you one possible value, but if the question is about how many possible values are there,
So in that
like
case,
that,
sir, we
yeah,
need to find all the values.
all possible.
Yeah, got it.
Okay, let's move forward and let's see the graph, how to draw the graphs of a function and what is a tangent. Mainly we will understand what is a tangent. What is the tangent to a graph? Okay, so graph of a function we have been seeing from week 2. So how do we draw the graph of a function? Whatever the points that satisfy the given function, we will plot it on xy plane and we will just draw a smooth curve connecting those points. So that means, see here, x comma f of x. So whatever the input I give to the function, I will get an output. So input comma output is a point. So all these points, I will plot it on the xy plane. So all these points, x belongs to the domain set. So all x comma f of x points, I will plot on xy plane, and I will just smoothly join all the points, and that curve is called the graph. Okay. So after drawing the graph, there are few tangent lines. So there are lines called tangent lines to this curve. And what is a tangent line means is, you can see here a tangent line. Sorry. Okay. A tangent line to a curve C at a point P. So you see now, tangent lines are defined or drawn at some point. Okay. While you read the statement itself, you should identify few things. So what is this statement saying? What is this statement saying? A tangent line to a curve C at a point P. So at a point P means at some point P. So tangent lines are drawn at points, at some points. Often has the property that it passes through the point P. So that particular tangent line passes through the point P, but does not intersect the curve C. So if this is curve C, and let's suppose say this is point P, what is our tangent line? A tangent line to a curve at point P often has the properties passes through the point P. So it has to pass through the point P, and also it is a line. So possible lines that passes through point P are infinite. So this is a line, this can be a line, this is a line, like this. Like this. So there are infinitely many lines that can be drawn that passes through point P. But what is the condition? But does not intersect the curve C. So intersect means cuts it and going into the opposite direction. See, this is an intersection. So this is an intersection point. Okay. This is an intersection. So these two curves are intersecting. And this is called touching. So there is a
Yes,
difference
sir.
between, so this is intersecting. This is called curves are touching. Just touching. Okay. So understand the difference between intersecting and touching. So here you can see these lines, whatever the lines I draw, they are intersecting this curve C. So they are cutting and passing into the other region of the curve. So this shouldn't happen, it seems. So it should pass through point P, but this shouldn't happen. It should not intersect the curve C. So that means it should be somewhat like this. So this is called touching again. So this is called touching. So this line touches this curve at this point P. So L and C. So L touches C at P. Okay, this is touching, which is not intersecting. Okay, in any other point close to the point P. So close to the point P means this much is enough. Even closure. So very, very close also. So in this region, it shouldn't intersect. Passes through point P but does not intersect the curve C. Any other point close to the point P.
Okay, sir.
Hmm?
Okay.
Mm-hmm. Okay. What is this?
Sir, can we
Does
say
not.
that?
Hmm.
Sir, can we say that this tangent line will define the slope of this function? Will
Slope of this function. Correct. Okay. So yeah. So it should not intersect first of all, and then it should not uh, anywhere nearer to point P. It should not again cut the curve C. But after some time, the curve may be like this also. There it can intersect, but within this region, within this small interval, it shouldn't cut at point P, and it shouldn't cut at any other point close to P also. Okay, close means, see, as I said, close means it's not like one interval or zero point 0.1 interval. It is very, very, very close. So dx close. So very minute close. Okay, and the lines parallel and close to it either do not intersect C close to P. See, you don't require these things. And the lines parallel and close to it okay. So what this tells is, so, and the lines parallel, so this now this is the tangent line, and the lines parallel to this T, so lines parallel to T are like this, these lines, parallel lines. So these parallel lines either do not intersect C, so that means these lines will not cut this curve, black curve, anywhere nearer to closer to P, or see, this is also a parallel line. Okay, so this may or may not intersect C. Either it will not intersect C, this is the curve C, black curve C. Either these parallel lines, either it will not intersect C or intersect C in two or more points close to P. So you see here this curve, this line, just above line T1, just above line T1, it will actually intersect this curve at two different points. Similarly, this line also will intersect at two different points. So what this statement actually says is, the parallel lines which are parallel to this tangent line will either not intersect C, or if it intersects, it will intersect at two or more points. It will not intersect at only one point. It will intersect at two or more points. So like this. Okay, but see, you don't
Sir,
require
this
these
is
things,
sir.
even though.
No, no, okay, okay, okay. I'll just ask it in a while.
Yeah.
No, sir, I was trying to say if like this condition is satisfied for any tangent line at any point of the curve at a particular time, right? So with respect to that point, we are taking the tangent line. So this is
Yeah,
true. If we take another point and take another tangent line, so that is true for that condition as well. I mean, for that condition only, but not both at the same time.
Correct.
Okay.
No, you have to look at in two different conditions. So there are two different conditions. Okay.
Yeah. So that I was actually asking was like my question was like that. If it's like if they are totally different, or sometimes we are taking side by side two conditions that at the same time. Okay, got it.
Okay.
Sir, because the
Hmm.
every in different point, the tangent of the curve will be different.
Different.
Yes.
Correct. Okay. So you see here also, whatever this statement says is it's just the property. So if I take parallel lines which are parallel to this line L, either it will intersect at two different points or it will not intersect at all. Okay, it is talking about this statement is talking about the lines which are parallel to that tangent line L. Okay, but tangent line means it's actually touches at point P, and it will never touch at any other point close to this particular point P. Okay, this is the tangent line to this curve at this point P. Now you can see the example. So here is curve given to you and there are 3 lines given to us, L1, L2, L3. Now which one is the tangent line?
L2, sir.
L2. L2 will be the tangent line. So L1 line is a parallel line to L2 and it is intersecting this curve at 2 different points. And L3 is also a parallel line to L2, but it is not intersecting the curve. So that is the question asked. Where the following lines is the tangent at some point on the curve C. So L2 is the tangent line. Now you see this curve. Let C be the curve and 3 straight lines L1, L2, L3 pass through the point P in the following. So L1 is going like this, L2 is like this, L3 is like this. So which one is the tangent now?
L1,
L1,
sir.
To
sir.
the point
L1.
L1 is the tangent.
L1.
Okay. So L2 and L3 are intersecting at point P, intersecting this curve at point P. Okay. So L1 is the tangent. That is the feedback. See this curve. So C be a curve corresponding to the function f domain R to R, codomain R, such that f of x is sin x. So this is the curve for sin x. This one. The 3 straight lines L1, L2, L3 pass through the point pi by 2 comma f of pi by 2. So this in the following. Now the question is which of the following lines is the tangent? Again,
L1, sir. L1.
L1 is the L1 will be the tangent line. Okay. Yeah. So that's about revision of weeks 1 to 6. Okay. The only new thing, it's not new thing. The only thing we learned a little advance is what is a tangent line and how can we draw a tangent line to a curve at a particular point P. So this is very important. So tangent lines are drawn at every particular point on the curve. There will not be a tangent to a curve, common tangent. So tangents to a curve are drawn at each and every point. So at some point the tangent line may be different and another point the tangent line may be y is equals to 0. Maybe.
There is
Hmm?
group of the point is different, then there will be
Then
new.
the tangent change. Okay. So let's look
How
at
can we derive a tangent of a piecewise function?
see piecewise function is also a function, but it is defined in some intervals. It is defined. It follows some function, and in some interval it will follow some other function. So let's suppose say f of x is something like x when x is less than or equals to 0, and it is x square when x is greater than 0. So this is a piecewise defined function. So the behavior of this function will be a straight line till x is equals to 0, and after x, when x is greater than 0, the behavior changes to a quadratic behavior, x square behavior. Okay, this is called piecewise function. So the function is defined in pieces. Okay, now if you want to compute the tangent at a point P, okay, so if I wanted to compute tangent at point x is equals to 2, I will take the function as x square now, and I will compute the tangent, the respective tangent. If I wanted to compute the tangent at x is equals to minus 3, okay, let me take it x cube. If I wanted to compute a tangent line at point x is equals to minus 3, then I take function to be x cube, and then I will compute the tangent. So within that specific pieces itself, we can compute tangent lines.
I see.
Okay, yeah. So see, piecewise function is nothing but 2 or 3 function. In a particular interval, the function is following some behavior, and in some other interval, the function might not follow the same behavior. So if I say x cube throughout R, so the function is x cube throughout R. But here the function is not x cube throughout R. It is x cube in some interval and it is x square in some interval. And it may be, you can also complicate the stuff. So you can give different intervals and you can just say it is linear, x square, x cube, x power 4, something. So log x in some interval. So this is called piecewise. So in this particular piece, it is defined like this. In this particular piece, it is defined like this. In this piece, it is defined like this. So as tangents are at single points, so that point might fall in any one of the case, any one of the region. So in that particular region, how the function is behaving, you just take that particular function and compute the tangent line. Okay.
Is it not possible to derive a tangent line at the point where one function changes into another? Suppose the previous example at x equals to 0. In case if we consider that x is not less than or equal to 0, but it is less than 0.
Okay, less than 0. And what happens at x is equals to 0?
Yes, sir, that's my question.
So you have to define, right? See, when you say my domain is set of reals, when you say if it is domain, then each and every point in the domain should map to any one of the value in codomain. Or if you just take r minus 0, 0 is your domain. R minus
It's
0
not
is your
possible
domain.
to define the tangent at x equals to 0.
Yeah, it will not be x is equals to 0 is not at all in our domain now. So there is no point of talking tangent line to the curve at point x is equals to 0.
I see.
Because that is not at all a point in our curve, on our curve. Okay.
Yes, sir. Thank you, sir.
So now let us see a new topic which is called limit of limits. And in that limits, firstly we look at the limit of a sequence, then we will look at limit of a function. So both are
Excuse me,
different.
sir. Sir, if x is equal to 0, then tangent will be the 90 degree, no? Tan 90 degree, then it will indefine.
What is tan 90?
Tan 90, that is indefined, no?
Tan 90 is undefined. How come tan
Means
90 came into this picture?
if x is equal to 0, then the degree of the with x-axis, the 90 degree will
It
be.
depends the
See,
nature of the
x is
card.
equals to 0 is not line now. X is equals to 0 is a point. I am talking about x is, if x takes value 0.
Yes.
It will depend totally nature of the card. On the nature of the card.
See, this particular curve we have defined it like this: x cube, 0 excluded, and x square. So now if I wanted to find the tangent at x is equals to 0, x is equals to 0 means it's the point here on this line. This is x is equals to 0, this is x is equals
Yes.
to 1. Okay, these are just
Yes.
the points on real line. So at x is equals to 0, if I wanted to, so his question is, if I wanted to find the tangent line at x is equals to 0, can I compute the tangent line or can I draw the tangent line? So our answer is, as x is not at all defined, or x is equals to 0 is not on our curve. So there the curve is braked. Okay, so the curve got braked there. So there will be a small minute gap between these two curves, this curve and this curve. So this particular point will not be on our curve now. So once it is not on our curve, we cannot compute the tangent. So tangent lines are computed at the points which are on the curve, not off the curve. Okay, this particular point is not at all on the curve, not at all in the curve. So therefore we cannot compute tangent line to the curve at x is equals to 0. At x is equals to 0. Okay, so whatever you are referring is this line, I guess. X is equals to
Yes,
0
sir.
means this line.
Yeah,
There
yes,
is a
I was.
difference between line and point now. Okay.
Okay.
Okay. So I am moving this top somewhere here. Now let us discuss about limit of a sequence. For that, we should understand what is a sequence. Okay. This particular denotion which you are seeing here, so an inside the third brackets. Okay. So this is called a sequence of a real numbers. So what do we mean by this? So what does this denotion represents? So what do we mean by sequence of a real numbers? What is sequence first of all? Anyone? Sequence. What is sequence? Okay, what is Q? Q.
So
Q U
sequence.
E U E.
The sequence is that
List,
where
sir.
the particular pattern, the number is increasing or decreasing.
Okay. Any other inputs? See, what is Q? What is
Ordered
Q?
list.
Ordered list. Okay, correct. So ordered list. So in English definition also, see what is a sequence? So arranging things in an order, right? In a particular straight order. So like this, something I will order here, 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 like this, right? And so on. So this is a sequence of some boxes. So box 1, box 2, box 3, box 4, box 5, box 6. So I have arranged these boxes in a sequence. So 1, 2, 3, 4, 5, 6, like this. So now this particular thing represents sequence of real numbers, it seems. So now my sequence contains real numbers. So if I have a sequence, if I say 1, 2, 3, 4, 5, so 0, okay, 0, 1, 2, 3, 4, 5, 6. So this is a sequence of natural numbers. Am I correct or wrong? So this is a sequence. So I am arranging now my natural numbers in order, in ascending order. 0, 1, 2, 0 comes first. So this in this particular sequence, 0 is the first term. This is the second term. Like this, third term, fourth term, fifth term, sixth term. So I know what is the 10th term, what is the 100th term, what is the 200th term in this particular sequence. This is a sequence of natural numbers. Like this, if I have a sequence of real numbers, so any real numbers, and that sequence, this particular an denotes, an is the nth term of that sequence. So if I wanted to write, so this is the explicit way of defining the sequence. It is a sequence of natural numbers. Implicitly I can just write this. So what does this mean is my nth term value is n minus 1. Okay, so an is n minus 1. You can check. So the first term a1 will be 1 minus 1, which is 0. A2 is 2 minus 1, which is 1. A3 is 3 minus 1, which is 2. So the inside an represents the nth term of the sequence. So like this, if I proceed, my nth term will be n minus 1. Okay, and so on. So instead of writing all these things implicitly, I can write just within the brackets n minus 1. So this is a sequence of real numbers now. So this represents a sequence of the real numbers where my nth term is n minus 1. Okay, so you have to be very friendly with these notations. Okay, I would say friendly. So unless you understand these notations clearly, it will always be confusing every time. So however you solve 100 problems or 200 problems on these sequences, if you don't understand the denotions or notations, what we use and what exactly that represents, you will again, so 201th question will always be new to you. Okay, so that is why I'm spending more time on explaining the notations first of all. So you should always be familiar and friendly with these notations. Okay, so this particular sequence, so this is a sequence 0 1 2 3 is a sequence, and then 1 by 2 1 by 3 1 by 4 and so on. This is also a sequence where the nth term is 1 by n. So I can write, instead of this whole sequence representing it like this, I can simply represent it like this within 1 by n. And there is 1 3 by 2 2 5 by 2 3 7
It's
by
like
2,
AP,
like
GP.
sometimes it may be AP, sometimes it may not be AP also. Okay, something like sin x, sin x, sin 2x, sin 3x, sin 4x. So this is not AP, right?
Also,
No, this is also a sequence: sin x, sin 2x, sin 3x, sin 4x. Okay. Or simply, this is, instead of x, just remove sin 1, sin 2, sin 3, sin 4, like this. So this is also a sequence of real numbers. Sin 1 is a real value, sin 2 is a real value, sin 3 is a real value, sin 4 is a real value. Like this. This is also a real sequence, and I can write it like this: sin n. So sin n is my nth value, nth term in the sequence. Okay. Every sequence is an ordered list, just like you have said. This is an ordered list, and this list contains only real numbers. And the nth term in the sequence, if you know the nth term, if you can generalize what is the nth term in your sequence, instead of writing all these things, all these 5 or 6 terms, you can simply write within this third brackets or proper brackets, curly brackets, sign that nth term. This an represents the nth term in the sequence. Okay, now just read the first statement, what it says: let this particular an be a sequence of real numbers where n belongs to natural numbers. Okay, okay, now you can get a clarity of what the statement says. So let us supposing that this is a sequence. Now I have a sequence. Okay, so once after having a sequence, that particular sequence is said to have a limit a. So every sequence may or may not have a limit. If a particular sequence is having a limit a, means if the numbers a n comes closer and closer to this value a as n increases. So what is this as n increases means? N increases means what?
Terms are increasing.
As n increases means in my sequence I am looking at the larger and larger terms. So this is the first term, second term, third term, nth term. So this particular nth term and 100, 200, 300. So this is what n increasing means: 300th term, 400th term, 1000th term. So the later values of my sequence. Okay. So if I say someone is standing to collect a movie ticket in front of a box office, so the first guy in front of you is the let's say he is the first person. So like this, if the person standing at the 100th person in the line, so that is the 100th term. Like this, 1000th term, 10,000th term. So in an box office, there will be at most 50 people. So the first person will always get a ticket. Okay, the second person might get. So 100% may or may not get the ticket. Okay, if the person is getting the ticket, so let us say it is represented as 1. So the first term in our sequence, now I am defining a sequence where if the person got a ticket, if the nth person got a ticket, my value of my sequence will be 1. If he doesn't get the ticket, the value is 0. Okay, so this is how I define my sequence is 1 if the person got a ticket, and 0 if he does not. Okay, how will my sequence look like? It will be 1 1 1 1 and so on 1, and after the tickets got finished, it will be 0 0 0 and 0. It continues to be 0. Correct?
Yes, sir.
Is this how it will be? Will it be like this?
Yes, sir. I mean, if we are
Can it be
just,
like this?
yeah, yeah.
No, sir.
No,
So
no,
if
no.
you are an
No.
Not
a
like the
movie
second
ticket
last.
seller, will you sell ticket to one guy and you will not sell to the next person, and you will sell to the third person like this? Will you do like this? Will we do like this?
No, sir.
No, right?
No, sir. No, sir.
So this is not possible. This is the only possible sequence we can have. So set of ones followed by set of zeros followed by some set of ones. Okay, now you see, as my this is a sequence now. This is a sequence of real numbers. As my n increases means as my n goes, if I see the later terms of my sequence, it will be 0 0 0 0 0 0 and it stays 0. So it means this particular an values, whatever the values we are going to get, will be 0 and it is closer to 0. Okay, so these all are zeros and these zeros are closer to 0. So these are approaching to some value 0, and therefore this particular sequence what I have defined, this particular sequence will have a limit 0. So some or the other time that ticket should be houseful. You cannot sell a ticket. Yes or no? At some time the tickets will be finished, right? All the tickets are sold out,
Yes, sir. Yes, sir.
Yes, sir.
and later you cannot sell ticket, right? So when you are not selling ticket, the value will be 0. So I am sure that the tickets will be sold out. So here also in a sequences, if I am sure that this particular sequence is going closer and closer to some value a, then I say this particular sequence an will have a limit value a. If not, so if I am not sure, as I increase n, my values are going far and far from some value, or it is going to two different values. See here, it should be unique also. It should go to unique a, only one value, or it is going to, or it is oscillating between two different values, then also limit does not exist. And if it is going far and far like this 1 2 3 4 5 6 7 and so on. So now you see in this particular sequence, as my n increases, my ans will be like a 100 will be 100, a 200 will be 200, a 300 will be 300. So these terms are nowhere coming closer and closer to some particular value, so it is keeping on increasing, right? This particular sequences will not have a limit value. So simply limit means if I have any sequence and I plot it on the real line, so consider this 1, 1 by 2, 1 by 3. So this is 1, this is 1, 1 by 2 will be somewhat like this, 1 by 3 will be like this, 1 by 4 will be like this, 1 by 5 will be like this, and so on. If I go 1 by 100 maybe like will be like this. Okay. So 1 by 1000, 1 by 10,000, and as I keep on increase my n, as n becomes larger and larger, my sequence value will go closer and closer to some value. So it is like 1 by 10,000, 1 by 1 lakh, 1 by how large I take also, it will not go beyond below 0. It will always be above 0 and it will come closer and closer to 0
So it
if you
so
observe
it
clearly.
tends to zero actually.
It tends to 0,
Tends to
but
zero.
it will never take 0.
Take zero, yeah.
It will come closer and closer to 0. Okay. As my n increases in this sequence, 1, 1 by 2, 1 by 3, 1 by 4. So as n increases means as I look at the larger and larger terms, not the values, terms. I'm talking about terms. If I look at the right side terms, as it terms, those terms will go closer and closer to 0. It will approach to 0. It will not go take the value 0, or it will not go take value.
So you're not audible, sir.
Not audible, sir.
Three by two, 2, 5 by 2, 3, and so on.
Sir, you were
Sir,
not
you were not
audible.
audible. Can you repeat, please?
Am I not audible?
You
Now
was.
you
Now?
are audible, but
Okay. So what am I saying is there are few cases where limit does not exist. Okay. First case is when this particular sequence an is not approaching or coming closer and closer to any a that is by 2, 3, and so on. These kind of cases, and there will be sine 1, sine 2, sine 3, sine 4, this also. So this will also not come closer and closer to some value like this. So in these cases we say limit does not exist, because this is not approaching or this is not coming closer and closer to some value a, so some real value a. And the second case is so if an is approaching to two different values. So for example, minus 1, 1, 1, minus 1, 1, oscillating sequences. Okay, see this one, and the next one is what can we have? This one. This will come closer. What can be the other examples? Can anyone help me out? So where, see, these kind of oscillating sequences I require. Am I audible?
Yes, sir.
Yes.
See, this particular thing, you see, will I say it is approaching to 1 or -1? So what will I say?
It may approach to 1 or it may approach to -1.
Yeah.
Approach to 1 -1 depending on the
Minus.
even or odd case. So that is why if it have two limit values, then also we say limit does not exist. Okay. And I am not able to recall some other examples. -1 by n.
Sir, we can have a sequence of uh, we can have a sequence of attendance of students like 1 for present and 0 for absence.
So that is not infinite sequence, right?
Yes, sir.
See, sequences in this real sequences are all infinite sequences. We require infinite sequences.
Okay.
Okay, like this. See, if I go explicitly, then I can get
1 square,
I
1 cube.
can 1 square, 1 cube, 1 to the power n, you mean?
Right. I mean, yeah. Or any number to the power explains.
That will come under this case, right? 1, 1, 2, 2 square, 2 cube. See, this will not approach to any value a, any real value a. These are called divergent sequences. So convergent sequence means, see here itself they have defined, I guess. Yeah, if the sequence has a limit, then it is called convergent. These are just the names, okay? That is why I didn't say. If it has limit, it is called convergent sequence. If it doesn't have limit, it is called divergent sequence. Okay, these are just the names. Just like we have 1 to 1, on to, surjective, injective. So the names. If a limit, if the sequence has a limit, then it is called convergent sequence. If a limit does not have a limit, then it is called divergent sequence. So these are all divergent sequences. Okay, explicitly I can give you an example. So 1 by n when n is odd, and it is 1 when n is even. Okay, so that is like this: 1, 1, 1 by 3, 1, 1 by 5, 1, 1 by 7, 1, 1 by 9, like this. So when n is odd means when all the odd terms, these are the odd terms. Okay, these are the even terms. When n is even, it is 1. Okay, when n is odd, 1, 1 by 3, 1 by 5, 1 by 7, 1 by 9, like this, 1 by 11. Now tell me, what is the limit of this function? Sorry, limit of this sequence. So limit
Limit
means
doesn't exist, sir.
As n tends to infinite, what happens to this sequence?
In odd, it will converge to 0, tends to 0 because it will decrease regularly.
Yeah, for
It is
odd.
1 by 11.
In odd, see, when odd case, it will approach to 0. Even case, it will approach to 1.
1, yes.
So this particular sequence will also have two different
Different
limit
values.
is why even in this kind of cases, if it is approaching to two different values, what we say is limit does not exist for that sequence. Okay. So these are the two cases. One case is it is not approaching at all to any real value, and the other case is it is going to two different values. Then also it is the limit does not exist. Okay. Yeah. So maybe in the next class we are just left with limit of a function. So just now we have seen limit of a sequence. So understand what is this sequence first of all, and understand how to find the limits. So there are few properties of limits also. So just go through the properties. I don't think the properties are difficult. The one thing is basically this is important anyway. So if each and every term is multiplied by a constant, if I have a limit which has a limit value at a, if I have a sequence which have limit value a, and in to that particular sequence, if I multiply any constant to each and every value, then the new sequence will have a limit value which is product of the constant times the limit value of a. So just look at these rules, and product of two different sequences will also go to product of the limit values. And what is important? This is called sandwich theorem. If I have the third sequence, consider two sequences where the first sequence having limit a and the second sequence having limit b. If I have a third sequence cn which is in between an and bn, okay, which is in between an and bn, every term is in between an and bn, then the limit value will also be so the limit of this sequence cn or the cn will also be in between a to b. So why this is important is because if I have two different sequences where both the sequences approach to the same value a, if it is approaching to same value a, if I have a third sequence which is in between these two, and if I don't know how to compute the limit of this sequence, then using the sandwich, you understand sandwich, right? Within two breads there will
Yes,
be
sir.
few things. So the top and the bottom both are having the same limits, then the middle one will also have the same limit. That is what it says. Just go through this. I don't think these are very difficult.
Sir, where can
Okay.
we find this PDF?
This PDF is actually the solve with us PDF. Solve with us assignment.
Okay, okay.
Okay. And in the next class we will start with limits of a function. Okay. So until now we never brought function into the picture. So that you have to keep in your mind. We have only talked about a sequence of real numbers, and then we talked about for that particular sequence whether the limit exists or not exists. If it exists, what is the value? If it does not exist, what are the possible cases? Okay. So in the next class we
One
will start with
one quick
yeah.
question. Probably it might have asked or addressed many
Mm.
times, but one quick question if you can help us. So, is there any book or reference to brush up our skills or to have like a more hands-on with the sort of problems? The reason I'm asking was the context or the concepts were I'm able to understand, but when I get to solving the assignments or the real problems, right, then I see some sort of like a difficulty or may not be I'm not thorough enough because sometimes I may get easily lost in understanding the logic or like the problem solving approach to be specific, right? So is there any book or any reference that we can have?
See, I understand. Have you saw this week 7, 8, 9? We have prepared a calculus book. Have you gone through? We prepared it.
Yeah, I went through that. what I'm asking, what I'm looking for was like see, I will give a blunt example, like for example, logarithmics, right? We understand the concept like a log a plus log b is equal to log ab, but at the time of solving the real case problems, right?
I
We,
understand
even
now.
though we know the concepts,
Yeah,
we're
I
having some
understand.
difficulty.
See, the things are. See, this is the first time a new course which is via mathematics I'm talking. Okay. So until now, no mathematics course has dealt with real life examples, and that too these many examples in any of the colleges or anywhere. So in any college, every mathematics course will be based on formulas. You just know the formula, you just apply, you just get the answer. So this is, see, in this IITM BSc online degree, this is the first course we are dealing with real life examples. Even I am including M1, M2 courses in engineering. So you might have done M1, M2, M3 in your BTech, right? So even those courses will not contain this real type problem approach. So what we can do is, we have given all the resources to you. These are whatever questions you are seeing, right? That real world examples, real life examples that are prepared by us. Okay. And we should write a book now. Okay. So you might get in online, you might get in some sites, you might get 1 or 2 examples or some 10 examples of real life, but there is, I hope there is no such kind of book as of now. It is being, it will be
So
prepared in future. If you want the problem approaching, just go through Google, just type whatever you require. You want an application problem in logarithms, type problem real life examples in logarithms, like this. But with regards to book, I'm sorry, as of now there is no such book. See, whatever if you want concept related examples, you can go through NCRT. If you want to get clarity of concept, you can go through that NCRT textbooks, class 11th and 12th. You will get an clarity. But real life, you have to you have plenty, right? Practice assignments, activities.
Yes, sir.
If you want uh, new examples, just whatever I said, just go through, uh, just open Google and just type whatever you want. If you want examples on logarithms, you just type real life examples in logarithms or applications on logarithms. Exponentials, you just type real life examples of exponentials, like this. You'll get some 10 or 15 such. Just try to solve that. Even the solutions will be available on it, I guess. If you didn't get the solution, you just bring to us. So you just bring the question to us, we will collectively solve the problem. Okay.
Okay, sir.
Yes, sir. When will
But
you
for
get? Sir,
when will
when
you
will
get?
you get quiz one result?
Someone said quiz 1 result is out.
Yes, sir. It's out.
Yes, sir.
Yes, it's
Quiz 1 result.
it is on the portal, sir.
Yesterday
It's on the
only.
portal under the My Courses section.
No, I
And
didn't get it.
You didn't see the My Course section over there. You can see the percentages for per subject, and on the top where you could see if you are able to write the qualifiers or not. Just below that, 3 lines or 4 lines, 3 or maybe 4 lines have added with your percentages and your
I am talking about quiz one, not qualifier.
acha, quiz
quiz
1
one
will
would be
come.
still there, right?
Term
Oh,
will come.
term. Sorry. Term, then it's different.
Yes, sir. Yes, sir.
Term will come within short time, maybe not on Monday. Monday is Diwali, right?
Yes,
Maybe
sir.
on Tuesday or Wednesday you will get.
Okay, sir.
And for week 7, 8, 9, there is a good book which was prepared by us. Okay, instructors prepared that. So there you will get some real life examples, and you can correct easily with lectures or whatever the practice assignments, graded assignments are there. So just go through that book. It's in supplementary contents. You can check textbooks. In that there is a calculus book. week 7, 8, 9. From now onwards, you have a standard book with you. So just follow that book.
Okay, sir.
Okay.
Okay, sir.
Okay, then let's meet
Sir,
in the next session. Yeah.
Thank you, sir.
Thank you, sir.
sir,
Thank you.
thank you, sir.
Happy Diwali, sir.
Thank you, sir.
Thanks. Yeah.
Yes, sir.
Everyone. Have a safe
Uh,
Diwali.
Deepavali.
Happy Diwali, sir.
Sir, I have a question that
Sir,
you
can
show
we
that
have a book
PDF
on week?
when we get,
Which PDF?
which are showing right now, just before this.
Whatever I
During the,
annotated, is it?
yes, sir.
Okay, I will upload it in the supplementary content only. Wherever
Excuse me,
you
sir.
get every time notes. How you get notes for live sessions? Where will you get this notes? Previously, you would have got, right? In previous weeks.
No, sir.
No, sir.
No one has uploaded anything till now, is it?
No, sir.
Okay, maybe you will get in the supplementary content only. Okay, we will send an announcement once we release this.
Okay, sir.
Okay. Yeah. Okay. Anything else?
Hello.
Yeah.
Sir, can I ask? See, sir, if we need to check if whether a function is reversible or not, then what are the things that we need to do?
Invertible or not, right?
Reversible or invertible are both means the same. So we need to find inverse of that, and if inverse exists, that means we can say that it is reversible.
Reversible, correct.
Okay, sir. Problem one solved. And sir, one more thing, not about maths. We have got this. What are the subjects we are going to study in the course? But is there anywhere else where the syllabus is also there?
Yeah, it is there, right?
Such number of courses and the name of the courses is there. But what I am saying is syllabus. What are the contents? Is it there?
Yes, it is there on
Future
In the
courses,
website
right?
only.
It will be there in the website. It will be there, right?
Sure, sir. I'll check. There is no problem in that.
Uh-huh.
And for this term, I have chosen mathematics and statistics. So I'm not going to submit the assignments of other two objects. And when in next term I'm going to opt the other two subjects, then all the assignments I need to start all over again, sir.
No, not all over again. If you wish to, you can do. If you want to improve your quiz 1 score,
okay.
So you can give quiz 1 and then the qualifier and that quiz 1, we will compare both the scores and we will take the best out of it. So let's suppose CT you have taken in the next term, okay?
Yes, sir. Yes, sir.
Now you might have got some score in qualifier, right? For CT.
Yes, sir. Yes, sir.
For CT. Okay, let's
Yeah.
assume that is 65 or 70.
Okay.
And in when that in that particular term, if you wish to do week 1 to 4, you can again study week 1 to 4 and you can again give quiz 1. Okay.
At
the and when you give quiz 1, in that quiz 1, if you got 80, maybe
yes, sir,
you got 80, then we will take best out of these two. That means 80 we will consider into your scores.
Okay,
so
sir.
your quiz 1 score is 80 now.
Okay, sir. Okay.
But if you are satisfied with whatever the score you got for qualifier, you can directly start from week 5.
Okay, sir. I got it. Thank you very much, sir.
Yeah.
Thank you.
Okay.
Excuse me,
Then.
sir.
Yeah.
Sir, can we have a book on week 5 and 6 content?
You see, it's under preparation. We are preparing it.
All
That is why I said as of now it is not available.
Actually, I was saying because I was unable to prepare for the week 5 and 6 content because of the qualifiers, right? So as a result, I need some sort of a reference book so that I can prepare on my own.
I
think it would be
understand.
very useful for other students as well who have missed the week 5 and 6 content because of the exams.
Right.
Thank
We
you,
understand. See, week 1 to 4 we have prepared and uploaded. Okay.
Yeah,
you
I
can
saw
check.
that. I saw
And
that.
week 7 to 9 we have prepared and uploaded. Week 5, 6 and graph theory part is being under preparation. So once it's prepared, it has to go to multiple reviews, proofreadings and everything. Once it is done, then we will upload it in the on the portal. We will try to finish it as soon as possible. Okay.
Thank you very much, sir.
Yeah, thanks a lot, guys, and We will meet in next session.
Happy Diwali, sir.
Happy Diwali, sir.
Yeah. Happy Diwali.
Happy Diwali.
Happy Diwali, sir.
Safe Diwali. And enjoy this week, okay? So study more, enjoy more.
Okay, sir.
Okay.
Okay, sir.
All right. Bye, guys.